As in the last lecture, we took two examples based on the type number 2a, which was in the form of integral 1 upon quadratic. So we took two example. One example when the coefficient x square already it was 1, and the second it was when the coefficient x square it was not 1. So we'll take one more example where we'll see if what the symbol of x square is negative. Okay, so how to present and how to solve the sum and how to apply the suitable formula. So as I told, whenever the symbol of x square is negative, you have to apply the third formula always. Okay, so already in the question, if it says that the symbol of x square is negative, see to that, no need of thinking much more. Out of this three formula, always the third formula will come, this one. Check the first and second, the symbol of x square is positive. So this two formula, when it will come, when the symbol of x square is positive, and third formula whenever already in the question it says that the symbol of x square is negative. So here we come to the conclusion that for this sum we have to apply the third formula. Okay, so let's move on to the step. As here also we have to make the coefficient of x square 1. As clearly we can see that already the coefficient of x square is 1. We have to make the symbol of x square positive. So now we'll move on to the next step. Of course, as I told, first we'll start with let I equals to integral 1 upon root 7 plus 6x minus x square into tx. Okay, so the next step will be what? We have to make the symbol of x square positive. So simply what you will do, you will remove minus common. Okay, so the negative term inside the bracket, it will become positive. The positive term will be what? Negative. I hope you all understood this step. Simply what you have to do to make the coefficient to make the symbol of x square positive, so simply you will remove minus, but see to that you will write that minus inside the root only. Okay, don't bring this minus outside. As I hope you all understood uh, the sums from the type number 1a, when we will dealing the sums with respect to the symbol when the symbol was minus. As in the last lecture when we will were dealing with the type number 1a, there we saw how to uh, make the symbol of x square positive. Okay, so here also same thing we will be doing. We'll bring this minus outside, but see to that minus you will write inside the square root only. Don't bring this minus outside the integral. Okay, so I hope you understood this step. Okay, so as you will bring this minus, you can check whether this step is correct or not. Just simply bracket open with this minus, so you will get the previous step. If you are getting the previous step, that means this step is perfect. As clearly we can see that when you will bracket open with this minus, so minus x square you will get minus minus plus 6x minus minus 7. Okay, now after this exactly what you have to do, you will keep this minus till where I will explain now. I hope you all might be knowing till where you have to keep this minus like this. Okay, so now 1 upon. Okay, so now we have to apply the third term. Second step, what is step number 2? We have to apply the third term formula. So what is the third term formula? That is half into coefficient of x. So here the coefficient of x is minus 6, the whole square. 2 ones are 2 threes are, so minus 3 square is what? 9. So here we got 9 as the number. So we'll make the pair like this here. So we'll add this number to alphabet, yes or no, and we'll subtract this number to number as it says in the step number 3. We have to add that number to alphabet and subtract that number to number. That only I did here. Whatever the answer here you will get, you will add that number to alphabet. So that's why, and each and every sum I am making this pair to for just understanding purpose. Okay, no need of making this pair like this. Okay, just for understanding I am making this design. So this is alphabet part and this is the number. So whatever the answer you will be getting, you will add that number to alphabet and subtract that number to number. Okay, after this I equals to integral 1 upon root minus, okay, this part, as here it is minus and plus, so this part we know that either it will get converted into a plus b the whole square or a minus b the whole square. As here it is minus and plus, so minus and plus, so it will be in the form of a minus b the whole square. So simply you have to see the first and last term. First is x minus square root of 9 is 3 the whole square. So we can write this step as x minus 3 the whole square. So when you will apply a minus b the whole square, you will get the previous step. If you want, you can check, solve this part in the rough work and check whether you are getting this step or not. If you are getting this previous step, then that means this step is perfect. Minus 7 minus 9, it is minus 16. Yes or no? Okay, so now after this adjustment, will bracket open with this minus. So when you will bracket open with this minus, what will happen? The negative number will become positive. So we'll write first 16 and after this we'll write x minus 3 the whole square. So whenever the symbol of x square is negative, see to that will keep the minus till this step. After this step, you will bracket open with this minus. So okay, in the next step, this will convert into the third formula. So we have to make the first, we have to bring the first number and then the alphabet, yes or no? So that's why I had bracket open with this minus to bring the number first and then the alphabet. As per the rule, we know that if this section it is in the form like what, the whole square, so we have to write the 16 as what, for the whole square, yes or no? As we are doing in each and every sum, as I told, after this adjustment only you will apply the suitable formula. I hope you all understood how to make the symbol of x square positive. Okay, bracket open with this minus. So what you will see, the first it will be number and second will be what, alphabet. As we know that if this section is in the form of whole square, so we have to write the number in the form of whole square only. So 16 we can write as 4 square. Okay, so clearly we can see that this look like what, the third formula. 4 is what, number, and x minus 3 is what, x. So what is the formula? If we integrate with respect to x, we will get sine inverse x upon a plus c. So I equals to sine inverse x upon a. What is there in place of x? It is x minus 3. What is there in place of a? It is 4 and plus c. Check if we can solve this sum further. I hope we cannot solve anything further, any step further, because x minus 3 and 4. Okay, I guess this is the last step. So this is the final answer for this sum. So I hope you all understood how to present the sum whenever the symbol of x squared is not positive, and how to make the symbol of x square positive, and then how to bring this minus inside, and then how to apply the suitable formula. I hope you all understood the third example also. Okay, so now we'll move on to the next sum. Suppose in the question, yeah, in the board exam sometime, if they will give this integral like this, 1 upon root x minus 3 x plus. Okay, so what exactly you will do now? As the denominator section, it is not a proper quadratic. Okay, so now suppose in the exercise there are 2 3 sum like this, and suppose in the board exam if you come across the sum like this, integral 1 upon root x minus 3 and x plus 2. So what you will do in the next step, same thing you will write. Let first step I equals to 1 upon root x minus 3 x plus 2 into dx. After this step, simply to make the denominator section root quadratic, so what you will do, simply bracket open. Okay, bracket open. So here you will see that x into x is x square plus 2x minus 3x minus 6. Okay, so the next step will be what, 1 upon root x square plus 2, this we can write as what, minus x minus 6 into dx. So this step actually it is what? X square minus x minus 6 into dx. Suppose we come across like this, we come across some based on like this, 1 upon root x minus 3 in the one bracket and x plus 2 in the second bracket. So if you have like this two brackets, simply what you will do, you will bracket open. Okay, so when you will bracket open, clearly we can see that we are end up with what? A quadratic form. So here after this step, 1 upon root quadratic, clearly we can see that this is the root quadratic, x square minus x minus 6. So as in it is in the form of what? Integral 1 upon quadratic, root quadratic. So of course after this step we have to follow the same steps, step number 1 2 3 4. I hope after this you all can do by the sum by yourself. As the step number 1 is what? To make the coefficient of x square 1 and the symbol should be positive. Already the coefficient of x square is 1 and the symbol is positive, and then after that you will apply the third term, and the rest I hope you all can solve the sum by yourself. So please try this sum by yourself whenever you come across the sum like this, 1 upon root. Okay, so simply bracket open, so you will end up with a quadratic form. After this the same step you have to follow, so where you will get the answer. Okay, as the symbol of x square already it is positive, so either the first formula or else the second formula will come. Okay, so I guess you all understood this step also. The same sum I guess it is there in the exercise. Okay, just bracket open and make in the form of 1 upon root quadratic, and after that follow the same step. Okay, so try this sum by yourself. So let's move on to some few example. Okay, so where you will see if what? The middle term is absent. Okay, and you have the first and the last term. If the middle term is absent, how to present your sum? As for the type number 1a also we had took some example when we saw when the middle term is absent, then how to present or how to find your answer. So here also we'll take some few example where we'll see if what? If the middle term is absent, so how to present and how to find our answer. Okay, so now we'll take some few example where we'll see if what? The middle term is absent. You will have this integral like this, integration 1 upon root x square plus 9. So of course you will start with writing let I equals to integral 1 upon root x square plus 9. As clearly we can see that the coefficient of x square here it is 1 and the symbol is positive. In the next sum, the coefficient of x square it is not 1, so here we have to make the coefficient of x square 1, and then after that we have to solve the sum, and the symbol is positive. And in the third example, as the coefficient is 1 but the symbol it is negative, and in all the three example clearly we can see that the middle term is absent. If the middle term is absent, so how we can apply this third term? The third term concept it is only for what? When the middle term is present. Okay, so remember whenever the middle term is absent, so you have to skip the second step and the third step like we did in the type number 1a. Simply you have to follow the step number 1 and step number 4. Step number 1, make the coefficient of x square 1 and symbol of x square should be positive, and directly you have to apply the suitable formula. Guess the formula, apply the formula, you will get the answer. You have to skip the second and third step whenever the middle term is absent. Okay, so we'll take will I took some few example based on that. Okay, so let's move on to the first one. So here we have integral 1 upon root x square plus 9. So if middle term is absent, so straight away what you will do, you have to follow the step number 1 and 4. No need of following seeing the step number 2 and step number 3, as the middle term is absent, so we cannot apply the half into coefficient of x the whole square. As we cannot apply the step number 2, we cannot move on to the step number 3. So in simple language, whenever the middle term is absent, first and last step will come. So here what adjustment you have to do? First step, check the step number 1, coefficient of x square should be 1. Already it is 1, symbol it is positive. Okay, so directly here this x square we can write as x the whole square, and this 9 I can write as 3 the whole square. That's it. Okay, and we come to the conclusion that as here the alphabet is there and here it is number and the connection is plus. So this look like what the first formula. So we'll apply the integral formula, that is integral 1 upon root x square plus a square into dx is what log mod x plus root x square plus a square. So we'll apply the formula. That means we are integrating with respect to x in the next step. So as per the formula, it says that the formula is what log mod x, what is there in place of x, it is x only, plus the same question you will write as here we have x square plus 3 square, okay, mod plus c. So in the next step, just we can write this x square as x square and 3 square as 9 plus c. That's it. Okay, so whenever the middle term is absent, see to that you have to see the first and the last step, skip the second and third step, because second and third step is for whenever the middle term is present. Okay, I hope you all understood how to present the sum whenever the middle term is absent. Whenever the middle term is absent, the sum is very simple. Just in idly 2-3 step you will complete your sum and you will get your answer. So let's move on to the next one. As clearly we can see that the coefficient of x square here it is 4 and it is not 1. So we'll make the coefficient of x square as 1 here. To make the coefficient 1, first of course you will have the integral, you will write let. So to make the coefficient 1, so just now only in the last lecture I had explained, you will write this, you will bring this 4 outside, like here will uh, bring this 4 outside means we'll make 4 as common, so we'll bring this 4 outside. So this will be x square minus 5 upon 4. If you feel that our step is wrong, so you can check whether it is right or wrong, simply bracket open with this 4. So if you are getting the previous step, that means our answer is perfect. So when you will bracket open, so this will be 4x square minus 4 will get cancelled and you will get 4x square minus 5 only. Okay, and after this we know that whenever we have a two term like this 4 into x, so this we can write as what 1 upon root 4 into root x. This all things I had explained in the last lecture, yes or no? So as here both the orders are same, so this we can write as like this also, okay, or this step we can write like this also. Okay, so here we have 4 and this section there are two section and the connection is multiplication. So when you will separate, as you will see that both the section as the same order, so this can be written as what 1 upon root 4 into the section second part will be also in root only. Okay, see to that, don't make this mistake. Okay, both the section are inside the root. After this, as per the rule, we know that whenever we have any constant inside the integral, so we can bring 1 upon root 4 as outside the integral. As we know that whenever we have any constant inside the integral, that means any number inside the integral, we can bring that constant, that number outside the integration. Okay, so after this, here we got x square minus 5 upon 4 into dx. I equals to 1 upon root 4. As the middle term is absent, so we know that what exactly we have to do and what step we have to follow. We have to follow the step 1 and step 4, skip the step number 2 and 3. We had made the coefficient of x square 1 and the symbol already it was positive. We'll check the formula now. As here we have x square minus and then number it is there, so minus. So yes, we come to the conclusion that we have to apply the second formula, yes or no? But the next step will be what, x we can write as x the whole square, and this we can write as what root 5 upon 2 the whole square. Remember this step. After this adjustment only you will apply the formula. Without doing this adjustment in each and every sum, don't apply the formula directly. Okay, remember this. In the next step you will write this both the section in whole square and then only you will apply the formula. So what is the formula? It is log mod x plus root x square minus a square plus c. So what about this 1 upon root 4? it will be same till the last step. Yes or no? As I told, as I had explained in many sum, log mod. So it says that what log mod x plus. So what is there in place of x? It is x only. X plus root, the same part will come. Yes or no? Okay. So the next, this will be what I equals to 1 upon root 4 log mod x plus root x square minus root 5, we can write as 5, and 2 square is what 4. That's it. Okay, if you want you can solve one more step, just cross multiply, you will get the answer if you want to solve. Okay, as clearly we can see that we can increase one more step here, 4 x square minus 5 upon 4. Okay, and here one more thing, clearly we can see that the square root of 4 also, we know that the square root of 4 is what 2. Yes or no? The square root of 4 is what 2. So this 4 square root of 4 we can write as 2. If you want you can write here only, here itself 1 upon 2 1 upon 2, or in the last step also you can show that step. As square root of 4 we know that it is 2, so we can write square root of 4 is 2 log mod x plus, so cross, so 4x minus 5 upon 4 plus c. Here also if you want you can increase one more step, x plus root 4x square minus 5. Okay, 4 can be written as what 2. Okay. Okay, I hope you understood the sum. It is on you, you can stop your answer till here, or if you feel that you can increase the step, it is on you. Okay, but see to that square root of 4 we can write as 2. I hope you all understood the sum number 2 also, how to present the sum. So let's move on to the last sum. We'll see if the symbol of x square is negative. Okay, see to that whenever the middle term is absent, the sum is very simple, just in hardly 2-3 step only you can finish your sum. Okay, as the middle term is absent. Okay, so when the middle term is present you have to follow all the 4 steps. Whenever the middle term is absent, just follow the first and last step, skip the second and third. So here the symbol it is negative, so whenever the middle term is absent, see to that directly we can solve this sum. As 16 we can write as 4 the whole square, and x square we can write as x the whole square. No need of bringing minus outside. Yes or no? That step we have to do when the middle term is present. When the middle term is absent, directly in the next step you will write the 16 as 4 the whole square and x as x the whole square. So we come to the conclusion that whenever the symbol of x square it is negative, already it is given in the question, so always and always the third formula will come. So what is the third formula? It says that integral 1 upon root a square minus x square we can write as what sine inverse x upon a plus c. Okay, so in the next step we'll integrate with respect to x, as this look like what, look like the third formula. Yes or no? So what is the third formula? It says that sine inverse x upon a, what is there in place of x? It is x only. And what is there in place of a? It is 4. Yes or no? Plus c. That's it. Okay, suppose in place of x square if there is any constant, so first we'll bring the constant outside, and then you will follow the following steps. And I hope you all understood this all 3 sums. And see to that whenever the middle term is absent, skip the second and third step, just simply follow the first and last step. And whenever the middle term is present, you have to apply all the 4 steps. I hope you all understood all the sums. As in the today's lecture we had covered the type number 2a. I hope you all understood the type number 1a as well as the type number 2a, and in the next lecture we're gonna see the type number 3a. And let's have a short revision exactly what we had did in the today's lecture. We started with the integral 1 upon root quadratic. We saw the steps. For type number 2a, there are 4 formulas, but basically in the exercise we use only 3 formulas. Okay, there is one more formula for type number 2a. Okay, when you will see the textbook, there are 4 formulas. Okay, but basically we apply only 3. So the first one is 1 upon root x square plus a square. The second one is 1 upon root x square minus a square, and the third one is 1 upon root a square minus a square. First and second formula you have to apply whenever the symbol of x square is positive, and third formula whenever already in the question it says that the symbol of x square is negative. For the first one, the formula is log. How to remember that also I had explained. Log mod x plus the same question you will write. Log mod x plus the same question you will write. And just for the third formula, remember it is sine inverse x upon a plus c. Okay, so in the lecture, in the last video lecture, we saw four sums actually, and the fourth one I told to solve the sum by yourself. And here in this lecture we saw three sums where the middle term was absent. Okay, so totally we had did 7 sum for the type number 2a. I hope you all understood all the 7 sums. Okay, and the remaining sums we'll see in the next lecture. In the next lecture we're gonna start with the type number 3a. Okay, so till then, goodbye, see you in next lecture.